Hey guys, welcome to the third video of 2.3 differentiation rules of products, quotients, and secants and tangents. So let's go ahead and continue the last video, and then I'll go ahead and talk about the tangent and the secants part. If you have a quotient in which the numerator is constant, it's easier to rewrite it as a function with the negative exponent and use the power rule. So here's what they mean by this. You guys already know that this is 9/5, and then this x squared comes to the top as x to the negative second. Using the power rule, drop the power, keep the constant, keep the x. Now take 1 away from the power, which is -3. Okay, so let me repeat that. Take 1 away from the power, and that becomes -3. And that is your answer. Now, you could use the quotient rule, but it would be very redundant because you don't it's only easier to use quotient rule when you have functions of x or higher degree of x or trig on the top and the bottom. In other words, this could easily just be power rule. But let me go ahead and show you by quotient rule. It's going to be the bottom times the derivative of the top. The top is 9, so it's 0, minus 9 times the derivative of the bottom, which is 10x, all over the bottom squared. What does that look like? Okay, well, this goes to 0. That becomes -90. X over 25x to the fourth. Well, x over x to the fourth will give me x cubed. -90, well, negative fraction, 90 over 25 is the same thing as 18 over 5. Okay, and that is the same thing as this problem that I just found here. It's -18 over 5, and then the x to the negative third, which means x to the positive third in the bottom. So those two are equivalent. So anytime you have a constant on top, just use the power rule. Now let me go ahead and show you the derivative of tangent. Now the derivative of tangent follows from the, the, the quotient rule. So let's go ahead and discuss, well, what is tangent? If you remember from trig, tangent is the same thing as sine x over cosine x. Now let me go ahead and use this as my u and v. It's going to be the bottom times the derivative of the top, which is cosine, minus the top times the derivative of the bottom, which is negative sine, all over the bottom squared. Well, what is cosine times cosine? Cosine squared x. Okay, so we usually denote square of a trig function in between the name of the function and the argument of the function. Or you can write it like this: cosine x squared. That is the same thing as cosine squared x. And then we have a minus sign, which is a plus sine squared x, all over cosine squared x. Now don't do this. I've seen this before. Cancel. No. Every time you do that, a baby panda dies. And don't kill baby pandas. You can't cancel fractions like that. But there is something you do know. In pre-calculus, you learn about your trig identities. Cosine squared plus sine squared is 1. So I'm going to replace that with 1 over cosine squared x, which is the same thing as secant squared x. And that is my derivative of tangent. Let me explain this part. Last year you learned the reciprocal identities. 1 over cosine was the same thing as secant. Well, 1 over cosine squared is the same thing as secant squared. So that is how I replaced this fraction with that expression. Now let me go ahead and do it with secant. Secant, we know, is equal to 1 over cosine. And then if you take the derivative using the product rule, the quotient rule, you get the bottom times the derivative of the top, which is 0. The derivative of 1 is 0, minus the top times the derivative of the bottom, which is negative sine x, all over cosine x squared. Okay, so let's go ahead and figure out what this means. That goes away. So I really just have a positive sine over a cosine squared. Let me see what I just did. Hold on. Okay, so yeah, okay, we're good. So I thought I had made a mistake. So so this is my derivative, but I don't like having fractions as my derivative, so I'm going to change this to something else. So I notice that I have a cosine squared, so I'm going to write it as 1 over cosine times sine over cosine. Well, why is that possible? I have two cosines, so I can separate them as a product of two cosines. Now, let's go ahead and go back to our trig identities. This is secant. This is tangent. And that is a much easier derivative to read. So the derivative of secant is secant tangent. So let's go ahead and state these rules. The derivative of tangent is secant squared, and the derivative of secant is secant tangent. Now, here's what I want you guys to do. I want you guys to challenge yourself and use the quotient rule to find the derivative of cotangent and cosecant. You should get negative cosecant squared if you use the quotient rule, and you should get negative cosecant x tangent, no, not tangent, negative cosecant cotangent x. Let me give you guys an easy way that I used to memorize these after I had proved them. Tangent and cotangent, they have the squares derivative on them. And then secant has secant tangent, but cosecant has the opposite. It has cosecant cotangent. So that's one way you could memorize these. Okay? But I want you guys to challenge yourself. Prove yourself this. Prove yourself that. And if you can do that on your own, I'll give you some extra credit. So let's go ahead and do our last example. Here we have 3x squared times tangent. This is a product rule. Product rule is u times v, u, v prime plus v, u prime. So let's go ahead and state this is u, this is v. So it's going to be u, v prime. What is the derivative of tangent? We just found that out. It's secant squared. Plus tangent times the derivative of 3x squared is 6x. Cleaning this up a little bit is 3x squared secant squared x plus 6x tangent x. And you're done.